Welcome to another event with Crowdcast, hosted by IBM Developer. My name is Demi Ajayi. I am the open source community manager for Call for Code for Racial Justice. And today we're going to be taking a look at one of our Call for Code for Racial Justice projects, the Incidence Accuracy Reporting System. And I'm very pleased and honored to have the team here joining us from all around the world. So everyone, please just wave, say hi to to our audience now. We'll also be having them speak obviously a little later on, just to talk a little bit more about the project. So before we get into the project today, which is a project that uses blockchain and machine learning to try to combat systemic racism, specifically related to police accountability. We will start by talking about what Call for Code is, and then also what specifically Call for Code for Racial Justice is. If you're new here to Crowdcast, you can post in the chat here on the right-hand side. We'll also have a poll that's being sent out, so I'll send a poll out into the, which you guys can also just access to provide answers to some questions that we have for you. We'd like this to be engaging, so if you have any questions, drop them into the chat, and we'll also answer them as we go along with the program. And then lastly, at the end, you can also click the Get Started button so that you can learn how you can get involved with this project as well. So with that housekeeping out of the way, we'll get started talking about what Call for Code is. So Call for Code is a global initiative that has been launched by the David Clark cause, where IBM is a partner. So essentially, Call for Code allows us to, is a platform that is centered around tech for good, and provides an opportunity for developers and non-developers to come together to better understand how to better find solutions to social problems. So we'll be having some slides that are coming up. Just wanted to make sure that everything is going well. Are we good there, Shonda?
Yes.
Okay, cool. I'm not yet seeing your screen. Oh, there we are. Great, excellent. Cool, thank you so much. So as I said, the Call for Code is a multi-year program that was founded by David Clark Cause, along with IBM as a partner, that allows us to have an annual competition that's around tech for good. And it's the largest tech for good challenge of its kind. So next slide, please. Basically, it allows, brings together developers to create high quality applications that are then open sourced, that are aimed to solve pressing humanitarian and social issues around the globe. And next slide, please. So essentially every year we have a Call for Code call to action. This year is around climate change. And this challenge is still going on till the end of July. So when you join Call for Code, you're able to join a community, build a team, build your skills, submit a solution for the challenge, and potentially if your solution is chosen, you're given $200,000 to support you in actually building this out, to getting this to be a solution that's used by the world. So essentially, we want to just not make this just like a one-time hackathon, but actually create sustainable solutions that are useful to fighting social good. Next slide, please. And as I mentioned before, the submissions are still open right now. So if you are interested, you can actually still submit your application until the end of this month, July 31st. And you can do so by going to developer.ibm.com/call-for-code to learn how you can get involved in the global challenge. And then if you have any questions, you'll be able to those questions will be answered once you join the Slack community as well. So if you're interested, we definitely hope that you're able to participate in that. Next slide, please. And just a little bit more about what Call for Code has done in general. As I mentioned, we are looking to create sustainable solutions. So we see here just some of the solutions that have been created so far. We have solutions that are used for early earthquake detection. We have solutions around helping farmers better understand when to plant, just based on the climate and the social or climate issues around them. Essentially, we had some solutions centered around COVID last year. And more recently, also in 2020, what we're here to talk about today is Call for Code for Racial Justice. So Call for Code for Racial Justice is another solution that was launched in 2020. So essentially, we had a challenge around solving issues related to systemic racism, and we're able to then deploy 7 solutions, one of which we'll be talking about today, which is IARS, related to just fighting systemic racism. And so, next slide, please. Call for Code for Racial Justice emerged as a response to just the issues that were happening or that were highlighted specifically in 2020. These issues, of course, have been going on for centuries here in the United States and also around the world, but there was greater attention, public attention paid to it last year. And as a result, IBMers were really looking to do something about these problems. You know, as a tech company, we wanted to see how we could leverage technology to address some of these issues. And so we devised 3 pillars that we were wanting to focus our attention on, at least initially. So police and judicial reform and accountability, which is where the incident accuracy reporting system sits, and they'll be talking more about their solution, looking to provide solutions that make it easier or more provide more transparency around police actions and policing in communities, and around the judicial system as well, to make it more equitable for people of color around the world, or in the United States specifically now, and hopefully eventually around the world. Also, diverse representation was another pillar that we focused on, and that was essentially to increase, to provide reduce bias essentially around the representation of Black people specifically, and also just minorities in general, in the workplace, also in media products, and also in society in general. And lastly, policy and legislation reform. So thinking about how policies are also maybe perpetuating racism or institutionalizing racism essentially. So looking to find ways to improve the future of legislation by using technology to provide instances of bias, or making information more accessible to people so they can exercise their voting rights. Next slide, please. So as I mentioned before, we have 7 solutions which we're going to talk about today across these different pillars. And so you can learn more about them by going to our website, which I'll also put in the chat, so you can get more information if you're interested in contributing to them. So we'll talk about IARS today specifically, but we do have 6 other solutions around these 3 pillars that I've mentioned, where you can also contribute to them, as these are all open source projects. And with that, I'll hand it over to the team to talk a little bit more specifically about their projects.
All right, thank you. So I'll start off for our incident accuracy reporting system. Our team is called the Lions of Justice, and this is our project that we started last summer, as Demi mentioned in our call for code. And so I'm going to start with the introduction and our problem statement. So what we've noticed, of course, over the last few years is that police interactions with the Black community has been featured prominently in the news. And often these interactions have been tragic. So according to the Washington Post, since 2015, Black Americans have been killed by police at more than twice the rate of white Americans. And some of these incidents have actually been captured on video or witnessed by civilians. Unfortunately, despite the evidence that we often see captured on cell phone cameras, or in some cases, the officer's own body cameras or dash cam videos, sometimes what we find is that the incident report isn't always as accurate or aligned with what was witnessed or captured on video. Let me give you an example. So what you see on the left-hand side here is the original press release for the George Floyd incident that happened last Memorial Day. So you see here is that what was released by the Minneapolis Police Department was that a man simply died after a medical incident. But of course, we all witnessed the cell phone video that was captured. And despite various witnesses that were present at the scene, what we saw was something that was alarmingly different than what was observed and what was ultimately captured by even the officer's own body cam footage. So naturally, reports like this have left many civilians asking for transparency on how these incident reports are generated, and furthermore, the accuracy of the written reports, as ultimately only officers have the final say-so over what's captured in the report. So that's why all of us here decided to take the call for code and see how we can address these issues. This is our team, the Lions of Justice. I'll go into what our roles were for this project and how we decided to create a solution that could address the problem statement that I went through earlier. So as you can see on the left-hand side, this is our team Lions for Justice. The teammates who are here today is myself, Shonda Witherspoon. I was a user research in the project. Lucia Ramos was a designer. We have Abiola Asojo, who was a design architect, along with my twin, Shalisha Witherspoon, who was also a design architect. And then we have Tunde Olokodana, who was a developer for our team, Lions of Justice. So the theme that we decided to tackle for the call for code for racial justice was police and judicial reform and accountability. So we wanted to find out a way that we could have transparent and accurate data available to assess police behavior and be able to basically observe if police reports contain any false information or perhaps any other inaccuracies. So we went through many design thinking workshops in order to craft what exactly we would tackle for the summer. And ultimately we designed a hill that would allow us to identify what we would work on for last summer's call for code. So the hill is as follows. Internal affairs and civilians, such as witnesses, can both contribute to incident reports, which would create a tamper-proof record with all accounts of the incident. Additionally, the lack of transparent, accurate 360 perspective of cleansed data available to assess police behavioral infractions mean that police reports could be falsified or contain any other inaccuracies. So we wanted a way to be able to determine where the inaccuracies lie and have it clearly outlined by anyone who reviews such reports. So that is how our incident and accuracy reporting system was born. So I'll hand it over to my teammate, Lucia, who will go on to explain our solution, as well as any user research we had before developing it. Lucia?
Thank you. So our application, next slide, please. We kicked off our project with user research. And first of all, to understand how the police incidents are generated, we conducted first-hand interviews with police officers, with police complaint officers, dispatcher, police officers, sergeants, and other actors. And this allowed us to build a workflow of the reports. So first of all, we tried to understand how things work. Secondly, we tried to understand the feasibility of our solution, if it could really make a change. So we interviewed former police officers that were part of internal affairs to be sure that our project was going to be feasible. And lastly, we wanted to understand how civilians would interact with our solution and if they would do that. So we conducted user testing and service with volunteers to ensure that we were building something that was user-friendly and also useful. Next slide, please. So this is the result of the first mock-ups that we built of our application. And our solution is a content management application that captures statements, videos, audio from first-hand individuals that are related to police reports. So we have an interface for first-hand individuals to put information or data-related incident reports. Anybody can use this part of the application and upload information. Then we have an automated and manual flagging of inconsistencies and inaccuracies that are in the initial incident reports based on all the collected data. Also, we have cross-reference reports data with officer history on misconduct, so we know that, a mechanism for disputing claims in incident reports, and a backend to a blockchain to have the document stored in object store. So we know that this is tamper-proof. Next slide, please. So how does our application work? So you have the witness or the person who calls 911. This recording is sent to the PCO. Then you have the police officer that arrives there, and he has, well, his body cam, the interviews, the notes he takes, the photograph, etc. Then you have the system that receives all that information no? And with all that information and the witness report and whatever it is on that incident in particular, all is sent to our application where alerts are sent. So if there are any inaccuracies, it's going to be shown in that system. So to sum up, we did very thorough user research to understand that what we are going to do is not only feasible, but also it's going to be valuable for society. So thank you.
Right, so next we'll go to Abiola, who will provide insights on our system architecture.
Thanks, Sandra. Thanks, Lucia. So we'll start off, I'll be giving a brief overview of our architecture, and we'll start off with the context model. It shows a high level of our system. It shows the content management system, how the victim, the witnesses, and law enforcement and additional sources of information, data, video, interact with the system at a high level. Next slide, please. And this next slide shows a draft of our high-level solution. It shows how the witnesses interact with the police, the victim interact with the police, law enforcement, how the police will probably submit information into the system, and how the information submitted is all processed. So we considered all of this information, all this gathering in developing our architecture, right? A victim will call the police, a police interviews the victim or witnesses, and also reporters could also submit information. And next slide, please. So next we have the component model, which shows more of functional view of our system.
Sorry, there is some background noise that makes it difficult to hear you, Abiola.
Okay, is it better now?
Yes, it's better.
Okay, so were you able to hear the previous slides?
Yes, we were able to hear the previous slides. There just was some background noise, but it sounds clear now.
Okay, thank you. So the component model, which shows the flow, right? The user uploads documents to the platform, and then if the document contains video or audio, you run through the document. You run the document through the Watson speech to text to create the transcript. And if the transcript is in non-English, for example, it's translated to English or to English language for processing. Also, we have in our system validation of whatever information that is submitted using scikit-learn. And the information submitted is stored in cloud object storage, and is linked to a hash and stored in the Hyperledger blockchain. So this allows for authenticity of the information stored, which is the basis of our system, right? Accuracy and authenticity. Next slide, please. Finally, this shows our operational model. It also shows how the victims, the witnesses will interact with the system, submit information either directly into the cloud or via information to a police officer. And all of that is gathered into the content management system and all processed, as previously mentioned, for authenticity and accuracy. Next, we have a demo.
Thank you, Abiola. What we have here is a demo presentation as recorded by Kalanji, who was the developer advocate in our team. So I'm going to play the video that will show you how the system is able to detect inaccuracies and be able to highlight that from the point of view of a police sergeant.
I'm Kalanji Bankole, and I'm a developer advocate with the Emerging Technologies team. So today I will be demonstrating the Lines of Justice project. So what we have here is a dashboard that can be leveraged by members of the police force at varying levels. So whether they're a officer in the field or a detective or a supervisor. And this dashboard gives a overview of all cases that have been received by a particular police station, as well as any associated evidence such as audio and video files. And we also have visualizations of how many reports and complaints have been submitted over time, as well as a breakdown of their status. So the main purpose here is to essentially compare police reports with accounts from witnesses and victims and compare how similar their descriptions were. Afterwards, we then categorize the reports based on how many conflicting descriptions were detected. So if I go on and navigate to separate view, so this is a different section of the dashboard. So essentially, this is a witness report form. And basically, this section will be publicly accessible and allow for anyone to report a particular incident they may have had with a police officer. So they can specify the location, the officer name or badge number, and they can describe the incident in their own words. They can also upload files in this section. So for example, we'll go on and drag and drop an audio file. And then I can go on and click submit. So after clicking submit, then the audio file will then be transcribed through the Watson speech to text service. And then we can also see details for each report. So we can see the transcript, and then we can also, and then also in the background, then the raw file is stored in the IBM Cloud Object Storage Service. So essentially, we will take a hash of that audio file and store that hash and all associated metadata on a blockchain. So if there's any case where the original file is at all tampered within the Cloud Object Storage section, then that hash wouldn't match anymore, and that would raise a flag. Anyway, so that concludes our demo, and I hope you enjoyed watching.
So now, to go into more detail on the technology that was used, as shown in the demo, I'll hand it over to Tunde to go into detail. Okay.
All right. Thank you, Shalisha. So can you go to the next slide, please? All right. So we used various technologies in the course of developing this project. So the first set of technologies are IBM technologies. We have the Watson speech to text. That's to convert any submitted audio files to text. And then we have the Watson language translator. In case someone is speaking another language other than English, we can use the Watson language translator to convert that language to English. So all the submitted evidences can have a uniform language. Then IBM Watson Studio is used to do the machine learning, to run the machine learning algorithm to operate on the data sets collected from the witnesses. Then IBM Cloud Object Storage is where the data assets are stored. And so these are the open source technologies that we used. The Vue.js is for the front-end development. We have Docker for containerization, then FFmpeg for video recording, video, audio recording and processing. Then we have blockchain like Kalonji explained in the demo. That's for making the system tamper-proof, so that the submitted evidences cannot be altered or mutilated. Then we used scikit-learn for the machine learning and the AI aspect, AI development the backend AI development of the project. Next slide, please. So for the AI backend, the machine learning algorithm that we used is known as the k-means clustering algorithm. So it's an unsupervised machine learning algorithm. So what this does is that first of all, we collected some metadata as part of the evidences from the witnesses, metadata such as location of events, the time, the date, and perhaps the kind of crime or the kind of event that happened. And based on this, we will be able to identify evidences that are pointing to the same event. So when we get these evidences together, then we now put them through the clustering algorithm to see which of them are similar or which of them are pointing to the same incident. So here you see the circled, I mean these three evidences in the yellow circle. So those are belonging to the same cluster, representing a particular, it shows that the witnesses are pointing to the same incident. Already they have the same metadata, and now the descriptions are similar. So they are talking about the same thing. So those are the kind of things we are looking for, because it's possible that two different events occur at the same location. You can see these three red dots at the extreme right are also looking similar. And, even though they are at the same location, that's probably a different event. So that's why we are doing this. Next slide, please. Next slide. So now we did a simulation using some simulated witness statements, and then we got a sample police report as well. And then we put them into the k-means clustering algorithm just to see if this is simulated, by the way, so it's not a real police report versus witness statements. In this case, the police report is obviously different from the statements of the witnesses. So, but we are able to show that the clustering algorithm can recognize that. So here we see that there are two major incidences, like there are two clusters in the same location pointing to different events. And then we see the police reports at the extreme left, the bigger circle, the police report at the extreme left is not in any of the clusters. It's far away from the centroid of those clusters. So that tells us that the reports of the police is at variance with the submitted evidences by the witnesses. So these are the kind of things we want to show with this project to foster accountability, accuracy, in the reports that are being generated by the police. So if you have questions, we will be able to take those questions later. Thank you. Next slide.
Thank you, Tunde. So now I'll be going over to what are the next steps for this project and how you can contribute to this project based on our technology needs. Next slide, please. Okay, so we had participated in design thinking workshops with subject matter experts in order to help us identify potential adopters for this system that we created. So some of these SME organizations included Axon, which provides equipment for police and law enforcement. We worked with someone from the Office of the State Attorney of Florida, as well as the United Way of New York City, which is a nonprofit that's dedicated to helping low-income members of the community and strives to help rebuild relationships between law enforcement and the community. So what you see on the screen is a empathy map, which is a part of design thinking to help us understand our adopters, which would include law enforcement, police departments, as well as the citizen who would be the users of our system. So what we found out through this kind of activity with the SMEs is that we imagine that adopters may be saying things like the solution may be expensive due to the use of AI, but also believe that it can make the police department more transparent. We also found that they may feel some hesitancy on trusting the civilian input, based on the current, I guess, what's the word? I guess the interactions with police and the community, which have unfortunately been highlighted negatively. And then they also may feel conflicted on sides. Like, for example, in our solution, there are concerns that it could be some kind of hesitancy in adoption for the police department if it's not seen beneficial to them. Like, for example, we want to highlight the witnesses in order to share their account, but we also want to show to the adopter, which is law enforcement, that it could benefit them based on allowing their side to see if there's any inaccuracies and help with internal affairs. So we want to show that it's beneficial for both sides, both the law enforcement and the community. And that was what we want to explore by using the empathy map. And for citizens, we know, unfortunately, they may feel some mistrust toward law enforcement, and they also may feel hopeful for this transparency through the use of AI. But some concerns we imagine, and this was also from our user research, was that they may wonder, is their privacy protected? Are they able to upload this data anonymously, or will the police department pursue them based on this information? So we want to take all those concerns into account and what we can do for the prioritization and roadmap. So next slide, please. So in continuing working with our subject matter experts, we created a prioritization map in order to find some of the features that were the most needed or necessary to improve our solution based on our prototype. So we have some dimensions that we found out for some features. So this includes data trustworthiness, which can affect both the law enforcement and the citizen. We found trends in transparency. We found trust for citizens based on their data protection. And then we had also based on the truthfulness or accuracy of their reporting. Then we have the easy access and data upload for citizens, their trust on tracking incidents, and then automation based for the police as far as the automating this work for investigations and their trust. So we found, as you can see on the priority map, which shows the most importance high up and to the right would be the most feasible to implement, we found that the most important was easy access and data upload for citizens. So currently, as we see in the demo, we just have a way for citizens to interact using the web application, for example, on a desktop. But we found that it would be more simple for them to use a mobile application where they can fill out this information through an app and have that set up by using things like auto completion, taking things directly from their camera, and it would make it more easier for citizens to capture, just like they currently do through things like Facebook. Then next we have trust for citizens, such as data protection. So this includes things like potentially anonymous reporting or secure identifiers so that we can protect their PI. And then lastly, we want to also build a trust for police so that they can adopt the system. And for this, we found things like clear AI, such as the explainability of why a report was inconsistent, and clearly highlight the AI as in what were the inconsistencies found, so that the police can see if it was through typos or a mistake in the AI so that it could be retrained, etc. So basically trust, automation, and easeability. Next slide, please. So this led us now to a roadmap, which we're hoping to get contributors on how they can contribute to this project. So what we have is we have these dimensions such as the features and capabilities, the technical requirements, who's involved for these features, and the roles that are needed in order to complete. So first we have is the mobile application upload. So as we mentioned, we would like the citizens and witnesses to more have an easier way of contributing to the police report. And this is, we found, of course, would be through a mobile application. So some of the features we're looking at is uploading their account, such as that their description, any metadata, such as the time and location, and also objects such as their camera or pictures that they've taken. So we imagine the technical requirements would be for login, some kind of the mobile UI, and then the use of blockchain in order to secure their data when it's submitted. So for this, we would have roles needed. Yeah, so this is, for example, mobile app developers, those who are web application designers, etc. So this is how they contribute to our mobile app. Next, we wanted automated notification. So for example, if there's an inconsistency report, then we would like supervisors and police departments to get like an automated notification, like an email that there was a flagged inconsistency so that they can review it immediately. We would also like citizens to be able to track the progress of their submitted report so that they can see updates and I guess help build the trust that their account is being reviewed and and see how they contributed. So for this, we would need security or software developers in order to help build the automation into the submission process. And then lastly, as we spoke before, we want to help build the trust for the police department to adopt by checking the explainability and transparency through the AI. So for example, they want to see some kind of metrics or score of the inaccuracies that's being reported. Also, if we can clearly show what the AI had found, for example, in the K-means clustering, what was the inaccuracies that the system found in order to raise the inconsistent alert. So we just want the police department to be able to trust the AI process, review it in case there's an error, and just have a highlighted way in order for all parties to see what's wrong and then have accountability. So this requirement will require machine learning, such as K-means clustering, and other AI, such as the speech to text and retraining, in order to make more improved models that are able to find these inconsistencies. And so for that, we'll need data scientists, machine learning, and natural language processing experts. And hopefully this will improve our solution and help speed up the adoption. So next slide. So that's concludes what we have, including our next steps. And if you would like, please join us. There's a green Get Started button that you can click below, and this will allow you to sign up for IBM Cloud and immediately start contributing to our project. All right, so thank you very much. And we will now be open for questions. So please ask away, and thank you very much.
All right. Thank you all for that great presentation. Seems as if we have definitely some people who are interested in getting involved and learning more. So as Shalisha just mentioned, you can do so by clicking the Get Started link, and that will take you to IBM Cloud. And from there, you should opt into the Slack community. That's really where our conversations are happening. So you can get involved there as well. I'm also going to put the GitHub link, the right GitHub link, into the chat, so you can just get a head start, better understanding the status of the code, exactly what's going on with that. And we do have some questions here, and if you have some additional questions, we can please put them in the chat, and we'll also address them going forward. So the first question that I have here is from Upkar. Did you have to augment the Watson services with any additional training data?
Tunde?
Sorry, can you repeat the
Yes.
question?
Did you have to
again?
augment the Watson services, like a speech to text, Watson natural language translator, and maybe Watson Studio with any additional training? Did you have to do any kind of training?
No.
Okay.
No.
So it was just fine with the out of the box solution then.
Yes.
Okay. Great. All right. And then another question, which was answered in the chat, but just so that we can all get the response here, is this mobile friendly for the witness?
Right. So as I showed in the next steps, this is something that we would like contributors to help with. For the MVP, what we just had was in the dashboard, there was a section where citizens would be able to upload the data and anything that they witnessed related to a crime. But obviously, it'd be more convenient if citizens could just use an application directly from their phones and be able to record and then directly have that submitted to our back-end system for verification. So mobile application is definitely, I think, on the prioritization. That was the number one request to prioritize and the most feasible for our roadmap. So we're hoping that we can get mobile app developers to help with this.
Okay, excellent. Yes, so we are again plugging, looking for more people to contribute. So please do, if you're interested, click the Get Started link, and then that'll get you into our Slack community. When you opt in to Slack, in the form that you fill, you get an email inviting you to the Slack community. You can then register, you can then go to Slack, and then you'll be taken to the Racial Justice General channel. And from there, we'll be able to connect you. Also say hi in the channel so that we know that you came from this crowdcast, and we can get you plugged in specifically into the team's specific Slack channel as well. And then another question here, which you've answered, but just for the sake of everyone who might not be looking at this section, is what is the underlying metadata that clusters the police versus witness statements?
Shonda, will you answer that?
Shonda, you're on mute. Okay, let me see if I can try to unmute you.
I'm unmuted now. Okay, thank you. Sorry, I didn't realize I was on mute. Yes, so the underlying metadata information that typically allows, I'm sorry, I let a lot of background noise. Can someone go on mute? All right, perfect. So the underlying metadata would be something that basically allows supervisors to be able to link a police report to a particular incident. And the reason that this is important is because oftentimes when people call 911 to report an incident, a police report number doesn't actually exist at the time. So typically what you would have is just details about the incident that would allow you to correlate that the incident is reflecting the same exact incident. So Tunde mentioned this briefly. One of those things would be the date and time that the incident occurred. Another metadata information would be the officers that reported or responded to the incident. And another, of course, important one would be the location of the incident, or at least the general vicinity. So for example, let's say that you have something that occurs in a store parking lot, for instance. What you would have is at least a location like the latitude and longitude that would be reported by people who called 911 to, let's say, report a crime like a burglary. So the metadata for that would be the parking lot or the store. They have a similar latitude and longitude. So you would say a burglary that happens in this area around this date and time probably reflects to the same incident. And that metadata will allow it to be grouped and then allow that to be resolved as belonging to the same incident as reflected in the K-means clustering algorithm.
Interesting. Actually, that brought up another interesting point. So is it also, in terms of, you mentioned like the police officer information, is that something that can then be used as a means of maybe even tracking like a police officer's behavior on the witness side? Obviously, like on the police report side, we'll see all of the incidents that they have, but are you guys finding a means on the witness side to be able to extract that, the police officer name potentially, and maybe use that as a means of like finding some trends going down the line as well?
Yes, exactly. So, for example, if you could also see what incidents were reported belonging to a certain officer, either identified by their name or their badge number, which is typically how civilians might first be able to identify an officer. So, if you see a pattern of behavior by this officer with this badge number seems to be involved with similar incidents involving police harassment or maybe brutality, as reported by witnesses, and this will allow internal affairs or supervisors or sergeants to be able to see and establish a pattern that, hey, this officer seems to behave like this as recorded by witnesses. There might need to be some disciplinary actions taken for this officer.
And that can that be done even independent of the police report? So even separate, like even if there's not necessarily like a matching police report for every witness, just having like a lot of witness accounts. Does have to be like a one-to-one relationship between the eyewitness account and the police report within your dashboard, or can there also just be like a lot of witness accounts and what you said just now as far as being able to track that information?
Yes, they will, as long as there's a lot of incident reports. For example, let's say multiple witnesses report the same incident, and at the time there's not a police report number attached to this incident yet. That happens further down the chain of command. What would happen here is that when you see all this metadata, it would be clustered closely together. You would be able to see those details, such as the officer's badge number or name as reported in the system. And that would kind of raise an alert on the behavior of this officer.
Okay, great. There are a few other questions here, and we think we have some time. So another related question to the K-means clustering. Sunday, you already answered this, but just for the benefit of everyone else. How does the K-means clustering work? Is it on individual words, engrams? Like how exactly does it really compare the police account to the eyewitness account?
Okay, well, so generally when you're using machine learning algorithms, there's something that you do, you extract some relevant features. So during the feature extraction, in natural language processing, there are some words that are considered as stop words that could alter, that could affect the performance of the algorithm. Those are removed first of all. Then after removing the stop words, then you now, apply whatever feature extraction technique you want to apply. In this case, we use the TF-IDF, which is term frequency inverse document frequency. So from the concept of information theory, that when an information is scarce, it's probably very valuable. So, something like that. I won't be able to go into the full detail of that TF-IDF. So based on that, so we extract the most important features in each of those submitted description by the witnesses. And these are vectorized and passed into the algorithm. So the way the K-means algorithm works is that if we decide the number of clusters we want to have, and we can also let the data set determine the number of clusters that we will have. So based on the number of clusters, we will initialize a centroid. And once a centroid is initialized, so each of those entries will be compared. The centroid is like a location on a Cartesian plane. So each of those statements will be compared to the centroid based on the distance from the centroid. So the closer they are, they will be getting mapped together. So if you bring in, you have initialized a couple of centroids. So if a statement comes in, it goes to its closest centroid. It goes to its closest centroid. That's how you're able to map those incidents together and find that, okay, these witness statements can be clustered together. They are talking about a similar event or stuff like that. So I hope that explanation will do.
Okay, thank you. That's helpful. We had this question in the Slack, which I think you guys already answered, but again, just to bring more visibility. So the question was around whether or not a witness can keep a record of, I guess, whatever they submit. Is that a possibility?
Yeah, so currently what we do is when the user submits their account, we save it to the cloud object store, and then this is secured with blockchain in order to create the tamper-proof record of each witness account. as I mentioned in the roadmap, one thing we would like though is for the citizens to be able to track updates related to the account that they submitted. So for example, they can see if this was led to investigations, accountability, etc., just so they can see, I guess, more transparency on what it was that they contributed to. So hopefully we have developers who can contribute, allow this notification by allowing these users to have an account, maybe create user accounts where they can track everything that they were able to submit and saved in the Cloud Object Store.
Okay, great. Let's see. Another question here is, how long did it take to build the dashboard? It seems very, very detailed.
Yes. So if I recall, this took about 2 to 3 weeks. Our team, well, all the teams actually of Call for Code were given developer advocates. So these were additional team members who would help us with the development of the technical aspects of our project, since this was all of this was in addition to our J jobs. So we were really happy to get the extra help. And so one of the members, Kalanji, he was a developer advocate, and he was responsible for creating the dashboard and also the demo that came along with it that we showed during the presentation. But to add to that, I know Lucia is not pulled to the green room right now, but Lucia was one of the UI designers for our team. And so she actually was able to develop mock-ups ahead of time before Kalanji actually worked on it. And so we used mock-up things such as Figma, which produced actual code of HTML or CSS for our solution. And we also worked with, with Figma. And we also worked with actual police complaint officers and sergeants from the Miami-Dade Police Department. And they provided us with another mock-up of how the screen is for how the screen is for supervisors and sergeants who actually review reports, so that we could try to mock that up as close as possible to what would be seen by them on their end. Lucia, do you want to add anything to that as well? You're on mute, Lucia.
It has to happen at least one in one meeting. No, we built it on Figma, so we had all the style class and stuff, and then I built the HTML like graph, and Kalanji with Bootstrap and other libraries we started working together to make it very quickly, saying, okay, this is this style, and making all the adjustments. So that also helped. And he used a Bootstrap library for the technology that we were using. So we had those things that made it more quick. And the importance of having the research and being able to reach users and say, hey, is this screen okay? And we had to change it many times to make it more realistic, or to the flow of the report and stuff.
Interesting. Yeah, that's really cool work that you guys have done. Another question, I saw that with our poll results were that no one actually on our call so far has built a blockchain before. So I'd like to know just a little bit more about your experience with the blockchain and how difficult maybe it might have been to implement that, or if someone's interested in joining your team, how much they would need to know about blockchain to get involved.
Yeah, so I wish that one of the developers here, her name was Laura, was able to work on that. Abiola, would you be able to speak on the blockchain that was used in terms of the architecture and how much someone with experience would need to get involved? You're on mute, Abiola, but maybe.
Yeah,
no problem.
Am I off mute
yes,
now?
We can hear you.
Yes. So, like you mentioned, Laura, also a developer advocate, worked on that. From my experience, I believe the blockchain, their training, if you're not familiar, you can use the IBM cloud training to learn about blockchain. So that's available. I'm also not a blockchain expert. So she did the work bringing in the data into the blockchain process.
Okay, great. Yeah.
And I think it's a good point, Abiola. Since we looked at a lot of IBM technology, I guess one of the benefits we have is like going through cloud. There's a lot of tutorials and startup recipes that they call them in order to learn these technologies such as blockchain. And hopefully, even though the majority of people here have not worked with blockchain, which included most of the members of our team, then we're able to still understand enough on a high level and actually have starter code on how you can create a blockchain solution.
Excellent. Yeah, great. And also we'll put more information into the IARS Slack channel as well on blockchain if anyone's interested in that once you guys are signed up and everything. I'm not sure if you have any more questions. If you do have a question, please feel free to drop it now. Otherwise, just want another reminder that if you're interested in getting involved further, please click the Get Started link, and that will take you to signing up for IBM Cloud and joining our community through our Slack channel. And again, you'll get an email when you opt in, and then you can join the Slack community that way. So I'll just give it another minute for any more questions that we may have. Otherwise, we'll be able to close up. You guys have any other parting words for our audience here today, just about your solution or anything else?
I just want to thank everyone who joined and wants to, continue answering the call for code. I think that our next step slides were presented well by my twin Shalisha on what we would be looking for in terms of skills in order to have this in the hands of adopters. And I think all of us here really think that our solution is important because, as stated in the problem statement, a lot of these incidents that were observed by witnesses, that wasn't the first time that happened. It's been going on for a very long time. And unless, people, create solutions or work together to be able to address these kind of issues moving forward and allow solutions like ours to be in the hands of the community and the police department, then we don't know when we might see real change. So I'm glad that all of us here and the other members of our team was able to answer to the call for code. And we hope that the rest of you do as well. It's a really important, and I'm really glad that we were part of this last summer.
Thank you guys so much. And thank you so much for contributing to this solution and being a part of Call for Code and Call for Code for Racial Justice specifically. You guys have done amazing work. Also, again, I want to say thank you to our audience for joining today. Thank you for your participation. We look forward to connecting with you on future Crowdcasts or also within our Slack community. We hope you'll join us there and get engaged. Also take a look at our GitHub page so you can start seeing how you can contribute as well. All right, thank you all. We're gonna be ending now. Thanks, bye.
Thank you, everyone. Bye.
Bye, everyone.